Good morning, Year 12. So this is hypothesis testing lesson 3. So we have looked at why we would do a hypothesis test, how to set up the hypothesis, the null and the alternative hypothesis. We've looked at significance and what a critical value is, and a critical region and an acceptance region. So we're going to take it a little bit further. So I've got here a question that you looked at last lesson. Okay, we've got a football coach claimed that he lost only 15% of his games, and one of his players think that this claim is inaccurate and decides to test at the 5% significance level. A random sample of 50 games is taken, and the critical values for the number of losses are 2 and 14. So first thing I did was set up the hypothesis. Well, the null hypothesis is always what you think, or what we're assuming is true, which is that the P, or probability, of a game being lost is 0.15. The player thinks this is inaccurate. He doesn't say whether it's bigger or smaller than that, so we're just saying that P is not equal to 0.15, which means we've got a two-tail test. So this tail here and this tail here. So first thing we've got here is this 5% significance. So what does the 5% significance mean? Okay, so 5% significance means it's the probability we reject the null hypothesis incorrectly. Okay, so we've decided that if an answer comes in this region here or this region here, so 2 or less or 14 or more, we would say the null hypothesis isn't true and we'd reject the null hypothesis. But we need to be aware that actually it is possible under this null hypothesis to get values here and here. It's just very unlikely. So 5% is the probability that we reject the null hypothesis incorrectly. What I want us just to understand here as well is, because it's a two-tail, that 5% significance level is spread out between the two bits. So we take the 5% and we halve it, and this bit here is 2.5%. and the top is 2.5%. Okay, so still got 5% of rejecting the null hypothesis incorrectly, but we could do that down here or up here, and we split the significance between the two. Okay, so very quickly, just to remind us how we were doing this question last week. State whether you accept or reject the null hypothesis if in the sample 3 games were lost. Well, 3 is here above the 2, so that's in our acceptance region, so we would accept. Okay, 15 games would be here above the 14, so that's in the rejection critical region, so we would reject. Okay, and 14 games, now 14 is here, is my critical value. Okay, so 14 is the critical value, so we reject the critical value as well. So we would reject 14 because it's 14 and higher. Okay. Okay, so in these questions you were told these two values, the critical values, but you are likely going to have to work these out. Now, there are 2 ways to answer questions, and you need to be able to use both methods, because you could be given, you might be directed to answer in a particular method. So what we're going to look at here is one way of answering these questions, and later in the course we'll look at the other way. So this way is to find the 2 critical values, or 1 critical value if we need one. So how do we find the critical values? Okay, so it's all about probabilities, because we are saying that under the null hypothesis, so in other words, assuming the null hypothesis is true, that the number of games follows a binomial distribution. So the number of losses, so x is the number of games lost, follows a binomial distribution of 50 and 0.15. So we were told up here that the critical value was 2. So what I want us to do is to look at the probability of being less than or equal to 2, because that's my critical region. Okay, so if you pop that in your calculator, in fact I can show you how to do that in case you've still struggled. If you've got a larger calculator, that's what I've got here. If you've got the ClassWiz, I will put a link again on Show My Homework because I haven't got the emulator for that yet. So if you've got the larger calculator, you press menu, go to menu 2. Okay, you've got, we'll talk about the lists later, but you want to start by pressing F5 to get the distribution, and then we're doing a binomial distribution, so press F5 again. And we are looking at this, the CD, the cumulative distribution. So this is the probability that we are less than or equal to. So we're going to press F2. So to start with, if we're only looking for one value, we're going to start with the data being a variable. Okay, and I'm looking for the probability that I want less than or equal to is 2. Let's execute that. And then the number of trials we said was 50. And the P was 0.15. Okay, and my answers are going to appear in list 2. In fact, I might just change that for now and put that in. There we go, for now. Okay, so that's the probability that x is less than or equal to 2. So okay, so the probability x is less than or equal to 2 is 0.1418. I do the same again and look at, change the 2 for a 3 and look at the probability that x is less than or equal to 3, and that comes out as 0.046047. Now I needed that critical region to be 2.5%. So the probability of being less than or equal to 2 is 0.014, which was 1.4%. Okay, and this one would be 4.6%. So I can see that 2 would be in the critical region and 3 would be outside the critical region. Now because it's binomial, there's nothing between 2 and 3. It's either 2 or it's 3. So the line is actually between the 2, but we say 2 is our critical value because it's the first value you would reject. So although this isn't exactly 2.5%, okay, it's the first value in that region that we would reject. Okay, now if we're going to look at the top region, okay, it's slightly harder. Okay, we're going to look at, we were told that the critical value was 14, so I'm going to look at the probability x is greater than or equal to 14, but I'm also going to look at 13 and see what the probability of being greater than or equal to 13 is. Okay, now greater than or equal to is much harder to do because your calculator only does less than or equal to. So what I need to understand from the binomial distribution is that if I want to work out greater than or equal to 14, I need to do 1 minus less than or equal to 13. Okay, so if I just write out a few numbers here, so let's have 11, 12, 13, 14, 15. I'm looking for greater than or equal to 15, and that would go all the way up to 50. Okay, so if to find that, I know the whole thing would add up to 1, so I need to take away less than or equal to 13, so I'm taking away this. Okay, so this is what I needed on my calculator. So again, using your calculator, work out the probability that x is less than or equal to 13. That, and 1 minus that is 0.01316, which is 1.3%. Okay, similarly, greater than or equal to 13 is 1 minus less than or equal to 12. That comes out as 0.03, so that's going to be 3%. And again, I need that critical region needs to be 2.5%. So 14 would be the first value in that critical region, but 13 would not be in that critical region because the 3% is bigger than the 2.5%. Okay, so that's what we've been through there, is just shown you why 2 and 14 were the critical values for that question. What we need to do now is to work out how we're going to do that. Okay, so here's the first example. So we've got x is binomial distribution 30 and proportion p, and our hypotheses are, the null hypothesis is that p is 0.2 and the alternative hypothesis is p is less than 0.2. We're asked to find the critical region for x if the significance level is 2% and then state the conclusion if x equals 1. So I've put some steps here, what we need to do. Okay, we'll look at these regularly as we do the more problematic questions, but number one is decide whether a one or a two-tailed test is necessary. So this bit here tells me it's two-tail, and because it's a less than, I know it's a lower two-tail, so I'm looking at the left hand side here. Okay, all right, so it's lower end. And I know that's 2%, so I know I need that region there to be 2%. Okay. So under the null hypothesis, so this is what we're assuming, that p is 0.2, x is binomially distributed 30 and 0.2. Okay. Step 2 was to write down H0 and H1. Well, that was done for us. Now we've got to identify the critical region based on significance level. Okay, so what I'm going to do, this is where we are going to use our calculator, and you can do this on the ClassWiz and this calculator. The steps you need for ClassWiz shouldn't be that different, it's just how you access your statistics, your binomial calculations that will be different. So under the null hypothesis we've got 30 and 0.2, so here's my calculator. Let me exit this one. Now I'm going to exit completely because I need to put this in a list. Okay, so what I'm going to do is I'm going to put in, right, first of all, I just want to show you how you clear your lists. Okay, so if you're on this calculator here, you would press F6 and you have this delete all, which is F4. So if I press that, it deletes everything. Press F1 to delete, and then if I move into list 2, okay, I can do the same, delete all, yes. Okay, so go back to F6, we come back to this distribution menu. So I want to put in list 1 all the values for the probabilities that I want to calculate. So I'm looking at the lower end, so I probably want to start with looking at the probability less than or equal to 0, less than or equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. Go back up, put 10 in. I probably want to do 11, 12, 13, 14 and 15. Okay, I've done quite a lot there. You might find you don't need that many, but it's probably better to put in more now than later. Okay, so I've put all my values in there, and then I'm going to tell the calculator to put the probabilities in list 2. So we're going to come to distribution, which is F5. Again, we're going to do binomial. And again, we're going to do the cumulative distribution, which is CD. Now, what I've got here is data is variable. I want to change that to list. So you can do this in your ClassWiz calculator. If not, I have put a YouTube clip on Show My Homework to show you how to do that. Now, my data is in list 1. Okay, so my number of trials this time is 30. Okay, let's put 30 in there. And my proportion is 0.2. Okay, now at the moment I'm not saving the results anywhere, so I do need to want the results saved, so I'm going to change that to list and put it in list 2. Okay, so when I press execute, now it's calculated all these probabilities here, but I haven't got down. Do not rely on these numbers here. These are not the numbers you typed in. So don't make the mistake I did and think, oh, that's probability for 1 and that's probability for 2. It's not. What I would suggest you do now is exit, and you get the lists here. So you can see the probabilities calculated for each value. So the probability being less than or equal to 0 is 0.0012. Less than or equal to 1 is 0.0104, okay, and so on. Now we need the probability to be 2% or 0.02 or less. Okay, so anything over 0.02 is not going to be in the critical region. So this is definitely going to be in the critical region. 1 is definitely going to be in the critical region. 2, 0.04 is not going to be in the critical region. Okay, so I know my critical value is, the line is going to be somewhere between 1 and 2, but the first number I reject is going to be 1. Okay, so if we come back to the thing here, I've written that down here. So we're looking for the probability of a particular value being less than or equal to 2, and we've worked out that the probability that x is less than or equal to 1 is smaller than 0.02, and we could see that on the list. Okay, so what we're going to write on our diagram here is that 1 would be in the critical region, but 2 would not be in the critical region because the probability being less than that was greater than 0.02. So hopefully you can see that. Okay, so the critical region, just to write this down formally, the critical region is x less than or equal to 1. Might write symbols in. The critical region is less than 1, and acceptance region, okay, is x greater than or equal to 2. Okay, and we did a lot of that last lesson, identifying the critical region and the acceptance region. Okay, so critical region here, acceptance region here. So the question said, state the conclusion if x equals 1. Well, if x equals 1, I would definitely reject the null hypothesis, but we would write it like this. There is sufficient evidence to reject the null hypothesis at the 2% level. So the exam board have said to use this wording, there is sufficient evidence, okay, and you must state the significance level, because when the significance level changes, your result might change. Okay, so if I made the significance level smaller, I might then accept or not reject the null hypothesis. So it's really important you state your significance level and use the wording there is sufficient evidence to, okay, or to not. Okay. Okay, so we've got another example here. What I suggest is you watch my first example, okay, because this one is looking at the upper region, which is slightly harder to do, and then you might want to pause and have a go at parts 2 and parts 3 and see how you get on. Okay, but I'll go through it all anyway, so it's up to you. Okay, so we've got 2 hypotheses set. It's as I said, it's one tail, and it's at the upper end, okay, because it's a greater than. So I've put that here. And the null hypothesis would be, not got it written there. So under the null hypothesis, we would be looking at 80 and 0.7. So let me, okay, so this is the distribution that we're going to be using. Okay, so here's my critical region at the top end. So I'm looking for a value x here such that the probability of being greater than that is 0.01 or smaller. Okay, so have a think about that. So the probability x is greater than a particular value here. It's got to be less than or equal to 0.01 to make that critical region 1%. Okay, now as we said before, we can't do greater than or equal to on our calculator. We can only do less than or equal to. But you need to remember, let me go back to the diagram, that we've got a binomial distribution. So if x is in the critical region, okay, let's draw that x in there. So it's not normally on the line, it's normally that side of the line. Oops, I've only got half an x. Okay, the first value this side would be 1 below it, would be x minus 1. Okay, so for x I would reject, and for x minus 1 I would accept. So what value would this bit take? Well, if this is 0.01 here, okay, this area over here would be 0.99, because I know the whole probability has to add up to 1. So another way of writing this, okay, is to say that we're going to look for the probability that x is less than or equal to this value here, x minus 1, is 0.99 or greater, because if this is smaller than 0.01, if I have to move that line up a little bit, then this bit will get greater than 0.99. So that's what we're looking for. So that's what I'm going to look on my calculator. I'm looking for values that give me a probability over 0.99. Okay, so we're going to go to the calculator and type in 80 and 0.7. So let's just clear the lists quickly. Okay, so I'm going to F6, go to distribution, go to binomial, and there. We'll come back to list 1 in a minute, I haven't filled it in, but we're going to put 80 in there, and I'm going to put 0.7 in there. Now I'm just going to exit that for a minute because I need to put some values in my list 1. Oh, that needs to be 0.7. Okay, so let's exit that. Okay, so I'm looking at the top end now. Now the top number was 80. I think initially I'm going to start with 80 and then maybe go to 75 and then 70 and then 65, just to give me an idea what's going on. Okay, and then might maybe refine that in a minute. Okay, because what we're doing is a little bit of a sort of trial and improvement. So let's go back to my binomial distribution. I've got everything filled in. They've got numbers in the list. It's 80 trials. P is 0.7. Let's press execute. And remember, I'm going to exit to get the numbers next to there. Okay. So I started with, if we scroll up a bit, I started with 80. The probability of being less than or equal to 80 is 1. Well, I'd sort of expect that. 75 goes to 0.9999, 70 is also similar. 65 is still over 0.99, okay, but we're getting close to 0.99 because it's 0.992. So I might now go back and type in 65, 64, 63, 62 and just see where we go from 0.99 to lower than 0.99. So again, I'm going to clear my lists. Let's just delete that list. Okay, and I'll delete the other one as well. So we said we'd start with 65 because I know that's just over 0.99. Okay, so we said we were going to look at 65 and around 65, so I've gone 65 down to 61. We're going to go back to our distribution, binomial and cumulative. Okay, so just double check, everything's in list 1, number of trials is 80, P is 0.27, and answers are in list 2. Remember, I'm going to exit to get to the list. Okay, if we go up to the top, we see 65 was 0.992, 64 0.9839. So I was looking for probabilities greater than 0.99. So 65 is the one I need. 64, it's gone too low. So let's go back and have a look at our working. So the probability that I'm less than or equal to 65 is greater than 0.99. Now I know 65, okay, is actually the number that's still in the acceptance region. Okay, it's the one before. So therefore 66 is the number I'm actually looking for. That's the other side, that is the first number in the critical region. So the critical region is anything greater than or equal to 66. Okay. So then to answer part B, state the conclusion of x is 64. Well, x is 64 is going to be in my acceptance region, so I would not reject. Oh. Okay, H0. You can say accept, but we're actually saying we're not going to reject it, okay, because 64 would be down here. Okay, all right, have a go then at changing the percentage significance to 5% and 10%. Pause it, have a go, and I'll do the solutions for you. Okay, so this time we're looking for a significance level of 5%, so this is 0.05. So just to follow this, I need a value of x such that the probability of being greater than that value is 0.05 or smaller. Okay, which means in terms of looking up on my calculator, looking at the other side, I'm looking for a probability that x is less than x minus 1, okay, so the value this side, and it's got to be not 0.95 or bigger on this side, okay. So if we go to the calculator, we'd already done this work now, so these are what we had up before, but I can see 63 is 0.96, 62 is 0.94, so the value I'm looking for is 63. Okay, so the probability x is less than or equal to 63 is more than 0.95. But remember, that's the one on the left hand side, 63, so the critical value I'm looking for is the other side is 64, so the critical region, x is greater than or equal to 64. So if we come to part B, if x is 64, I am going to got sufficient evidence to reject the null hypothesis. Okay, and the last one, it was 10%, so in a similar vein, okay, the value, I'm looking for a value where the probability of being greater than it is 0.1, so if I turn that round, the probability that x is less than x minus 1, so the value on the left hand side, has to be 0.9 or greater. Okay, using my calculator. Okay, so using my calculator, I've put in a few more values. We were looking for greater than 0.9, so 61 gave us 0.91. I come down, 60 gave us 0.86, so it's got to be 61 is the first one, greater than 0.9. So we come back here, we get less than or equal to 61 is our first value. But again, that's the one on the left hand side of the line, I need the one the other side, so the critical region is x greater than or equal to 62, so again we would reject the null hypothesis there, and again get the wording, it should be significant evidence to reject the null hypothesis. So we're going to move on to part C. So it says the null hypothesis is rejected at the p% significance level when x is 64. Find the smallest possible whole number value for p. Okay, so we know we rejected it when at 5% significance level, but could I have made my significance level slightly smaller or than 5% and still reject 64, or is 5% the smallest I could make that? Okay, because we didn't reject at 1%. Okay, so move that down here. Right, I could do with a picture. Okay, so I know I'm going to reject at 64. Okay, that's the first number I'm going to reject. Okay, I want to work out what this percentage could be. Okay, it could be 5%, but is 5% the smallest it could be? So we're going to start by looking at the probability that x is actually greater than or equal to 64. Okay, so that would be 1 minus less than or equal to 63, okay, because as we said before, you can only do less thans on your calculator, so we have to look at less than or equal to the number before, and that comes out at 1 minus 0.969, which gives us 0.03, which is actually 3.02%. So to the left, to the right of 64 is 3.02%. Now we were asked for a whole number. Okay, so if I put a line in there and say, well, that is 3.02%, could I say that could I round that and say my rejection, my significance level is 3%? Well, if I said my critical region was 3%, that would be over this side here, and so I would not be rejecting 64 at the 3% level because this is slightly bigger than 3%. So therefore, the lowest percentage as a whole number has to be 4%. So my so I've put it here at 3%. We would accept 64. Okay. So the significance needs to be 4% so that 64 is rejected. So the smallest significance I could have is 4% so that 64 is rejected. But we also know from before, when it was 5% we rejected, and when it was 10% we reject. So we've rejected other percentages, other significance levels, but 4% is the smallest significance where I would still reject 64. Okay? Hope that makes sense to you. Now, over here we've got some questions, okay? I will just make my screen, if I can. There we go, so you can see all the questions, okay? Obviously you can pause that. If you need to make it a little bit bigger, you can zoom in if you need to. So watch number 2, because it's a two-tail. So we're looking for 10%, but that means you've got to do 5% either side. Okay, so you've got to look at the lower end and the upper end, but it's 5% either end. So just watch that one. Okay, this one is fairly straightforward, and number 8 is similar to the one we've just done on number 9. Okay, number 10, 11 and 12 are of the type we've just looked at, okay, finding the significance level, either the greatest or the smallest. Number 12 is quite tricky, but have a go. Okay, it's asking for 2 possible values of A, and see if you can have a go at that, but I've got solutions coming up in a minute. Okay, so these are the solutions. I've got it on dual page so I can see the questions. So on this one, number 2, the null hypothesis was 20 and 0.4. Okay, and we're just asked to find the critical region for this one. Okay, so again, I've given the lower end a value, called it x1, and the upper one called it x2. That's my only discrepancy really. So we're looking for a value such that being less than this value is 0.05, okay, and being greater than this value is 0.05. So this one's nice and easy. Put it in your calculator, and the first value that comes up is 3. That's less than 0.05, so your critical value is 3. So the first part of your critical region is that x is less than or equal to 3. Remember, the upper ones are slightly harder, so you do greater than or equal to, and remember we look at the other side of that, which means we're looking at less than or equal to the number before, has to be bigger than 0.95. That should come out as 12, okay, if you do use your list value on your calculator, which means the number we need is the other side of the line is 13, so the other part of the critical region is that x is greater than or equal to 13. Number 6. Okay, something's going on. Okay, so number 6. So again, under the null hypothesis, we're looking at 30 and 0.15. So that's what you need to put in your calculator. This is an upper tail test, and it's one tail, and the significance level is 15%. So we're looking for a value such that being greater than it is 0.15 or less. So again, if we flip that round, the other side of that line is 0.85, and we're looking at the number before, and the probability has to be 0.85 or more. So again, I've got a mistake there. Let's get that as 8. So that number there is 7. Probability less than or equal to 7 is more than 0.85. So that comes here, which means the number I need is 8, and therefore the critical region is x greater than or equal to 8. Okay. So here's the answers to number 8. Okay, if you need me to go through that in more detail, I can, but your critical region for part 1 is 26, x greater than or equal to 26. Part 2 is x greater than or equal to 23, and part 3 is x greater than or equal to 19, which means that in part B, you'd accept the null hypothesis for part B, you'd accept the null hypothesis for part 2, and you'd reject the null hypothesis for part 3. Okay, so part C, it says the critical value for the p% significance level is 21. Use your answer to part A to find an inequality for P. So, at the 0.2%, the critical value was 26, so that's way over here. And at the 2%, the critical value was 23, so again that's here. So at 2%, the critical value is here, this side of 21. But at 20%, the critical value was 19, which is this side of 21. Okay? So, therefore, 21 is between 23 and 19. Okay? Therefore, the significance value has got to be somewhere between 2% and 20%. So all they're wanting for here is that P is between 2% and 20%. So that's nothing else required for that. There's no great calculations, it's just using this information here. Okay, it can't be 2% because that had a critical value of 23, and it can't be 20% because that had a critical value of 19. It's got to be somewhere between those two. Okay, so moving on to question. Okay, so question 10. Under the null hypothesis, we get a binomial distribution of 40 and 0.4. And we're looking at one tail lower, and we get that from the hypothesis here. And it says the critical region is x less than or equal to 8, and the significance level is y%, and we're trying to find what y is, what the greatest value of y can be. So we need to look at, well, what's the probability of being less than or equal to 8, and that's 0.6, okay, and we need the whole number, so the greatest value whole number is 1%, okay, for 8 still to be in the critical region. Okay, and as just as a double check, I've looked at the probability that x is less than or equal to 9, which would be the one in the acceptance region, and that's 1.5%. So 1% is the greatest significance whole number that this could be if 8 was the critical value. Okay, question 11. So again, under the null hypothesis, x is 50 and 0.05. And again, we're looking at a one-tailed lower. Okay, find the critical region for x if the significance level is 10%. So there's my 10%. Again, on my calculator, I'm looking for the first value where the probability is less than 0.1. So I've got it here. So 0 is 0.07, that's less than 0.1. But 1 is 0.27, so that's greater than 0.1. So 0 is the first value where the probability is less than 0.1, and so therefore the critical region is x is less than or equal to 0. Okay. Part B, find the smallest integer value for x such that the critical region at the x% significance level is different to your answer to A. Okay, so A, we said the critical region was 0. So for us to change that, we're now saying that we want the critical region to be, critical value, to be different. So the only thing it could be is 1. So I need to put 1 in the critical region. If 1 is in the critical region, what is the significance level? So we need to look at the probability of being less than or equal to 1, which is 0.2794. So the percentage level that would include 1 would be 28%. So it would have to be a 28% significance level if 1 was going to be my critical value. Okay. Question 12. Now this was the difficult one. Okay. So question 12 was two-tailed. Okay. And under the null hypothesis, it's 60, binomial distribution 60 and 0.2, and it's two-tailed because it's a not equal to. We're told the critical region for x is 6 and 18, so I've put those in, 6 and 18. So 6 is the first number we would reject on, and 18 is the first number we'd reject on here. And we're told it's a 2A% significance level, so we would split that 2A into an A% and an A% either end. So either end is A% each. Okay, find the two possible integer values of A. So what could A be if I'm going to reject 6 and reject 18? But we also need to think about the numbers just inside the acceptance region as well. So if we look at the probability that x is less than or equal to 6 is 0.03, and that gives me 3.84%. So my significance level here would have to be 4%. Okay, but greater than or equal to 18 gives me a significance level of 4.3%. So that would have to be, I couldn't have 4% here, it would have to be higher, it would have to be 5%. So at the moment, okay, I would have to, my significance level would have to be 5% because I couldn't have 4% here, that would be too small, and these two have to be the same, okay? So at the moment I've got 5%, that's one answer. It could be a significance level of 5% where I would reject at 6 and reject at 18, okay? Now I could make that significance level slightly bigger, okay, for both of them, but I would need to make sure that 7 and 17 never go into my significance level, okay? So I need to now look at what happens at 7 and 17, which are the first numbers in the acceptance region. So the probability of being less than or equal to 7 is 6.696%. So if the critical region was 6%, I would still reject 6, but I would still accept 7 if that was the case. So now I need to look at 17. What's the probability of being greater than or equal to 17? Well, following this process of doing 1 minus, I would get 0.07, which is 7.7%. So again, at 6%, I would still reject 18, okay, because I'd have to do that at 4.3, and I would still accept 17 if the significance level was 6%. So the two possible values A could be were 5% or 6%, okay? So it wouldn't matter which of those I would choose, whether the significance level was 5% or 6%, I would still reject at 6 and 18 and accept at 7 and 17. Okay, hope that makes sense. Okay.